Okay, Tommy drops a pile of bricks from the top of a roof located 8.52 meters above the ground. Determine the time it takes the bricks to reach the ground. Okay, so the first thing I did when starting to solve this problem was to start to find was I actually started I drew my picture and shows you kind of what's going on here, and this is 8.52 meters from the ground, and the only thing stated in the question is 8.52 meters of what the brick falls. So we had to understand that the displacement of the bricks must be negative 9.8 meters per second squared, because the bricks are falling down. So that shows you that gravity is pulling the bricks downward, and it has an acceleration of how fast the gravity is moving, makes it move. So then what we know is that the initial velocity is 0 meters per second. The acceleration of the shingles is negative 9.8 meters per second squared because they're free falling, and then the displacement is negative 8.52 meters. So now you want to know what kinematic equation we're using, and we're going to use the displacement, which are the one d equals vi times t times 1/2 times a times t squared. So so the next step is to put the values in that we know, and use the proper use the algebraic steps to go down, and we get that 8.52 is equal to 0 meters per second times the time of 1/2 times negative 9.8 meters per second times t squared. And getting it down, we break it down until we get to here, which is t squared equals negative 8.2 meters divided by negative 4.9 meters per second squared. And then to get rid of the squared of t, we square root it, and our final second of how long it takes the bricks to fall is 1.32 seconds.